Okay, this is a lesson on 5.8 solving word problems using quadratic equations. So the first problem we're going to be looking at is an integer problem. Now we've done integer problems before, but we use linear equations to solve them. Now we're using quadratic equations. First problem is one integer is 5 less than 4 times another. Their product is 21. Find the integers. The problems we've done before involved sums. So product is what's going to create the x squared term, which will make it a quadratic equation. So let's start by defining our variable. So let's let x equal the first integer, and let's let 4x minus 5, since the second integer is 5 less than 4 times the other, that's why we'll define it as such. Now it says their product, so I go x times the quantity x, 4x minus 5 is equal to 21. So to solve this one, I'm going to have to distribute the x to the 4x and the minus 5, so it would be 4x squared minus 5x equals 21. I've got to get the 21 on the other side because I'm going to solve by factoring. And I get 4x squared minus 5x minus 21 equals 0. Now I was playing around with the factoring of this before, and I got that the factoring of this one is 4x and x and minus 3 and plus 7. Yeah, that works. Okay, now when I use factoring to solve by zero products property, I've got 4x plus 7 equals 0, and then I've got or x minus 3 equals 0. Now an interesting thing happens when we solve these two. We get that I get a non-integer solution with this part of with this factor that I used to solve the equation. So x equals negative 7 fourths, and I can actually do what's called exclude that solution because it's not an integer solution. So the one that matters is this one that generates an integer, and I get x equals 3, and then the other integer is 4 times 3 minus 5. So that's going to be 7, so the two integers are 3 and 7. Okay, let's look at the next type problem. This is what are called vertical motion problems, and when you have ones involve units of feet per second, you can use this formula, h equals vt minus 16t squared. And so basically you have an object going up and an object going down. And let me draw that down below here, what this formula is all about. So before we look at the first problem, if I have an object that's starting at 0 and it's going up and then back down and it lands back down, so this is 0 feet, and all along the way there's these different heights. Sometimes there are 2 different times then something can be at one height. There is an actual peak that it hits, at a certain point. But this is a height of h equals something here, h equals something here. You have 2 different times that it's at that height. You have h equals something here as well. At the peak, and then you have 2 different times. What I'm trying to say here is that there's 2 different times that it's at each height except for at the peak. So there's a time, t seconds right here. It's also at t seconds right here. And this height has 2 different t's. This has t seconds. different times than it's at these different heights. But except for when it's at its peak, there's two different times when it's at a certain height, because it's at that height going up and going down. So anyway, so in exploring this, you're going to be using this formula right here a lot. So let's look at this first problem. You has after how many seconds will an object hit the ground if it is launched with a initial upward velocity of 144 feet per second. So just a little bit more about the variables. H is the height at a given point in time. V is the initial upward velocity. T is the time that it took to get to that height in seconds. So I'm using this formula. Let's write the formula down. H equals VT minus 16T squared. Now, you have two T's in this. One of them is, they stand for the same thing, and yes, they are showing up twice in the equation. So what we're given in this one is that we're actually given one thing in disguise and one thing directly. We're given that V equals 144 feet per second. But we're also given the height of h equals 0 feet, because it wants to know how long does it take for the object to get back to the ground. So that's when it's at 0 feet. So we're actually, in our formula, we're going to substitute 0 for h. We know I have 144. So initial upward velocity is, how fast when it's shot out of the let's say a gun or a bow and arrow or thrown. What is the initial upward velocity? Because remember, the object slows down due to gravity, so that's why they say initial upward velocity. That's what V is here. So times t and minus 16t squared. So I'm going to solve this by, this one I can solve pretty easily by factoring. I have a common factor of 16. So I have 0 equals 16t as my common factor. And then I get 9t minus, or 9, not t, I factored the t out of there. So I get 9 minus t, all right? And so my two factors are 16t equals 0, and that's the time when it's actually starting, so that's kind of irrelevant, so we don't worry about that. It is a solution, t equals 0, but the other one's the one that matters, or 9 minus t equals 0. So I'm going to add t to both sides. I get t equals 9, and that's 9 seconds. So it took the object 9 seconds to go all the way up and all the way back down at that initial upward velocity. All right, let's go to the next one. Let's do another vertical motion problem. So this one notice it says, this one is not going all the way back down to the ground. It's got initial upward velocity, a cannonball initial upward velocity of 224 feet per second. At what times, notice plural, will it be at a height of 640 feet? So I'm going to again use my formula h equals vt minus 16t squared. Remember, I do have the height this time directly at 640 feet. And I have the initial upward velocity of 224 feet per second. So I'm going to substitute those in. So 640. So 640 equals 224t minus 16t squared. So I'm going to need to get the 640 to the side, so I have 0 equals negative 16t squared plus 224t. Now I didn't show that, but I subtracted 640 from both sides. Now I'm going to check for a common factor of I'm going to try to factor out a negative 16. And let's see if that goes into 224. I'm going to pause that and check that real quick. It does factor out, so I'm going to have 0 equals, I'm going to factor out negative 16, and then it'll give me t squared minus 14t, and then minus 40, or no, sorry, that'd be plus 40. And so I need factors of 40 that sum to negative 14. So that'll be, so I have negative 16, so that's going to be t minus 10, t minus 4. And then I'll go over here and I've got t minus 10 equals 0, or t minus 4 equals 0. And when I add 10, I get that t equals 10 seconds. And when I add 4 over here, I get t equals 4 seconds. So on the way up, after 4 seconds, the object's at 640 feet, and then on the way down, after a total of 10 seconds, so it's 4 seconds and 10 seconds when it's the object is at 640 feet. One on the way up, one on the way down. So next problem I'm going to, this is going to use the Pythagorean theorem, which is we've actually used before. You'll recall that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs or the sides that make up the right angle of a right triangle, and c is the hypotenuse. Remember, you spell that hypo, 10 u's of a right triangle. That's the side length opposite the right angle. So we can, now that we know how to solve quadratic equations, this should be a lot easier. So we'll call the h our a, so h squared plus 72 squared equals 75 squared. So let me pause it and do a little calculating here. So what I've got is h squared plus 5,184 equals 5,625. Then I'm going to subtract 5,184. And that will get me 441. So h squared equals 441. I'm going to subtract 441 from each side. Now, I think most of you know you could have solved it right from there, but since we've learned how to solve by factoring, let's just stick with that method for the moment. And, sorry, that's h squared. And 441 is a perfect square. That's 21 squared. So you get h minus 21, h plus 21 equals 0. So the one that matters is the one that's going to get us the positive answer. One of these we're going to exclude. So when we add 21, this is going to be our answer of 21 feet. Because the other one is going to get a negative length, and no such thing as a negative length. So we'll exclude that one and keep 21 feet as our answer. So you have the length of the base and the height of a triangle are numerically equal. Okay, so let's try to draw that. Let me get it how I want it, and then I'll turn back on the recording. I think I did pretty well here, roughly. So basically what it's saying is that the base, we're going to call that x, and we're going to call the height of a triangle are the same length, all right? So let's let x equal the lengths of the triangle's height and base. And it gives, in units, it doesn't give us actually what the units are. So I'll just say in generic units. So it says their sum is 6 less than the number of units in the area of the triangle. So let's let x squared equal the area of the triangle. Nope, I'm sorry, let's let 1/2 x squared, because it's 1/2 times base times height equal area of the triangle in square units. Now it says their sum, so the sum of the two is 6 less than the number of units than the area of the triangle. So I'm actually going to have to add back 6 to make, since it's 6 less than the area, so I have to add back 6 to make it equal to the area of the triangle, because I've got to make sure that I actually have an equation. So since the sum is 6 less than the number of, and it should have said the number of square units in the area of the triangle. So let's find the area of the triangle. So here we go. So let's go 2x plus 6 equals 1/2 x squared. And so let's, if we want to get rid of this 1/2 right here, actually we can factor that out later just so we don't have to deal with that. But let's subtract 2x, and then let's subtract, and then so that'll get us 6 equals 1/2 x squared minus 2x. And then I'm going to, whoops, didn't like that. Then I'm going to subtract 6 from both sides, get both sides equal to 0. And then I have 0 equals 1/2 x squared minus 2x minus 6. So I'm going to factor out a 1/2 so I don't have that weird lead coefficient. So I'm going to say 0 equals 1/2, and then I'll have x squared minus 1x minus 3. So I'll have 0 equals 1/2, and then I'll have x minus 3, x plus 2 would get me that middle term of -1. And so then I will have x minus 3 equals 0, or x plus 2 equals 0. One of these is going to get a positive. That's that one. So I have x equals 3 units. You can see this other one's going to get a negative, so I'll exclude that. And so now, but we've got to go back and answer the question here, which is find the area of the triangle. So if the height and the base are both 3, it's going to be, so the area, let me use green. So the area equals 1/2, well, the base is 3 and the height is 3, so it's half of 9, or so I'm sorry, that's not 1/3, it's 1/2. Half times base times height. So I'm going to have 9/2 square units is the area. And that's the end of the notes.